Hi, welcome back. So to continue on here, for example number 7, we want the graph of the functions represented by the following Maclaurin series. We want to find out where this graph intersects y equals x cubed. Well, if we take a look here, notice this kind of looks like e to the x. Well, we know e to the x is 1 plus x squared over 2 factorial plus x cubed over 3 factorial plus dot, 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 so on and so forth. But this one seems to be alternating. This looks like it might be e to the negative x, which is going to be 1. Just replace your x's with negative. I get minus x. This becomes a positive because we're squaring the x, so we get x squared over 2 factorial. And negative x cubed is just negative x cubed. So minus x cubed over 3 factorial plus dot, dot, dot. So we notice, yeah, this is just my e to the negative x function. And I want to find out where this graph intersects y equals x cubed. So they're saying, well, where does e to the negative x equal x cubed? Well, you would have to do this on a calculator. Whoops, can't spell calculator. On a calculator. So to do this one, you just solve it, y1, y2, and you get 0.773. And that's where they meet up at. Very easy. All right, so let's take a look at some AP questions here. All right, here we go. Question number 8 here. Excuse me. A function satisfies the following series, is defined by the following series. And for all x in the interval of convergence, they're just telling us that this is going to converge. We want to find the interval of convergence for this series. So again, it's interval of convergence. So we're just going to do this looking at your general term, and we're going to use that ratio test. So for part A, we take the limit as n goes to infinity of n plus 1 plus 1. So that's going to give me n plus 2, x to the n plus 1, over 4n to the n plus 2, flip it, 4 to the n plus 1 over n plus 1 times x to the n, and remember this has to be less than 1. Simplifying it, I'm going to give myself a little bit of space here this time. And let's see here, looking at the n plus 1s, nothing can cancel out there, so on top we're left with n plus 2, on bottom we got this n plus 1. Looking at the x's here, we're going to left with 1x on the top, and looking at the 4's, we'd wind up with 1 4 on the bottom is less than 1. And again, I can just factor those out, and that's going to give me the absolute value of x over 4 times the limit as n goes to infinity of n plus 2 over n plus 1 has to be less than 1. This is 1, so therefore we can say the absolute value of x has to be less than 4. So this gives me my radius. My radius is going to be 4. My center is 0. What we have to do now is go ahead and find the interval. Well, if I were to solve this, we're saying that x has to be between negative 4 and 4. So now we just have to check the endpoints. Checking the endpoints. The first one, let x be 4 here. If we let x be 4, we would get the series as n goes from 0 to infinity, plug in 4. What are we plugging here? Oh, 4 here. We would get n plus 4 over 4 to the n plus 1 times 4 to the n. Now, it seems kind of weird, but we can simplify this a little bit. If I were to simplify the 4s, I would just get n plus 4 over 4. And if we take the limit as n goes to infinity of this, that becomes infinity. Therefore, this diverges by our divergence test. So that's not going to work. X equals negative 4. And if I plug in negative 4, we go 0 to infinity. We would get the same thing, n plus 4. But now we're going to get this negative 4 to the n over 4 to the n plus 1. And honestly, we kind of simplify this down to the same thing here. Even though this one is alternating, we would get this negative 1 to the n. But this is the 4 to the n is going to cancel. We're going to be left with this n plus 4 all over just 4 again. And same thing as before, if we take the limit as n goes to infinity of n plus 4 over 4, this becomes infinity. So therefore, again, this will diverge by the divergence test right there. So neither one will work. Now, even though we're using the alternating series here, it's an alternating series, it diverges by divergence test. Don't forget about that. So our interval is just going to be from -4 to 4. Neither one's going to be included in that. All right, now for part B says take the limit as x goes to 0 of our series here. So if I take the limit as x goes to 0, we're just going to replace it. We've seen this quite a few times now. We would get 1/4 plus 2 over 4 squared x plus 3 over 4 cubed x squared plus ... And then, of course, it says minus 1/4 all over x. And I'm just simplifying. We can cancel those 4's out, and everything else has an x in it. So we can take the limit as x goes to 0. I'm going to divide everything by x now, and we would get 2 over 4 squared plus 2 over 4 cubed x. And all the other terms are going to have an x. And these all just go to 0. So what are we left with? 2 over 4 squared, or what's that going to become? 1/8? Yeah, 1/8 right there. B's easy. Part C, it says write the first 3 non-zero terms and the general term for the infinite series for the integral. So now they want me to evaluate this now. So if we do that, to do this, we would go 0 to 1. Plugging in, we would get 1/4 plus 2 over 4 squared. Let me see right there. 4 squared x plus 3 over 4 cubed x squared plus ... And let's see here. If I plug in my general term here again, I'm just going to plug in my general term. What's my general term? N plus 1, x to the n over 4 to the n plus 1, plus ... dx. I know it seems kind of weird to write it this. There, look, there's an integral of an infinite series. It just goes on. And now I want to evaluate this. We would get 1/4 x plus this becomes 2 over 4 squared times 2 x squared plus this just becomes 3 over 4 cubed times 3x cubed. If you notice, all those terms are going to cancel out. Plus, and if I do the same thing here, we would get what? N plus 1 over 4 to the n plus 1 times x to the n plus 1 over n plus 1 plus ... So all those are going to cancel out. Then I can do the same thing here. And I'm going to evaluate that from 0 to 1. So if I plug this in, if I just plug in 1, I don't have to worry about the zeros. We just get 1/4 plus 1 over 4 squared plus 1 over 4 cubed. And we only wanted the first 3 non-zero terms plus ... And our general term, plug in a 1 here, plug in a 1 here. And if we do that, we would get 1 over 4 to the n plus 1. And plus ... Don't forget that. And there we have it. Very easy to do. And the last part, part D, it says find the sum of the series determined in part C. Well, if we notice for part C, this is geometric. So how do you find the sum of a geometric series? It's your first term divided by 1 minus your common ratio. Our first term is 1/4. Our common ratio is also 1/4, which becomes 1/4 over 3/4, which if you reduce it becomes just 1/3. And there's a sum. Easy to do. All right, number 9. Here we go. Oh no, I'm thinking Lagrange. Honestly, ugh. All right. So for part A, we want to write a third-degree Taylor polynomial at center x equals 2. They give me the function and all the derivatives right there. So let's see here. So to go ahead and solve this one, write a third-degree Taylor. Remember, write it this way: P3 of x equals, the first term is 3 minus 4. We're centered at 0, so x, that means 2, x minus 2 minus 1 over 2 factorial, x minus 2 squared, plus 5 over 3 factorial, x minus 2 cubed. And there's our Taylor right there. We want to estimate the value at, what is it, 1.2? And that's going to become 3 minus, plug in the point 1.2. Is that right? So we get 4, 1.2 minus 2, minus 1 over 2 factorial, 1.2 minus 2 squared, plus 5 over 3 factorial, 1.2 minus 2 cubed. And if you type in your calculator, you get about 5.453. I'll just type it in for you. Part B now says the graph below to give me the fourth derivative. The graph of the fourth derivative is shown, and it has a horizontal tangent at 1.7. What that's telling me is that this is the lowest point on the fourth derivative right there. Use Lagrange error to explain why our approximation why the actual sum can't be 5.3. So we're talking about Lagrange error. So if this is Lagrange error, we're going to set this up. Remember, Lagrange said the error of our term is less than or equal to the maximum possible value of our next term over n plus 1 factorial x minus c to the n plus 1. So we're looking for the error in the third, which has to be less than the maximum possible value of, that should be a z, of our fourth derivative over 4 factorial x minus, and c here is 2, so 2 to the fourth. So what we need to do is we need to find the maximum value of our fourth derivative. That's what this is. The maximum value of the fourth derivative right here. And to get that, we just look at our graph. There it is. Right there. It's 3. And it occurs at x equals 1.2. I just plug it in. I plug in the 3 over 4 factorial, and this becomes plug in x. Our x in this case right here is again 1.2 minus 2 to the fourth. And if you type this in your calculator, you get 0.0512 by Lagrange error. So why is our error not there? Well, let's get the actual sum. Well, what should the sum be? The value at 1.2 is going to be our approximation 5.453 plus or minus this 0.0512. So therefore, the actual value at 1.2, and I'm going to use a calculator for this one. I'm going to cheat a little bit. Is going to be between 5.402 and 5.505. So therefore, the 5.3 is not in the domain or the interval. In the interval, so it won't work for us right there. All right, the last one, part C. All right, they say write a fourth degree Taylor polynomial for f of x equals g of x squared plus 2. Use p to explain if it has a relative maximum or a relative minimum. So, well, this is, we're talking about a Maclaurin, so we can just change it up. So we know p3 of x, remember, so p3 of x, our original, was this, 3 minus 4, x minus 2, minus 1 over 2 factorial, x minus 2 squared, plus 5/3 x minus 2 cubed. Well, f of x, so g of x, as a polynomial is going to be, remember, g of x is equal to our x squared plus 2. So this is just a straight up substitution. I can just substitute it in. So g of x is this, which is going to be approximately, and I just plug this in, 3 minus 4. This becomes x squared, what's that? Plus 2 minus 2, minus 1 over 2 factorial, x squared plus 2 minus 2 squared, plus 5 over 3 factorial, x squared plus 2 minus 2 cubed. And I can just simplify that. And that becomes 3 minus 4x squared minus 1 over 2 factorial, and that just becomes x to the fourth. And let's take a look here. What did we want to find? We want to find a fourth degree Taylor polynomial, so we're done. That's my fourth degree, and it's 4. So we're done. Right there, there's our answer. So we can say that our fourth degree Taylor is going to be this. Right there. We're not done. We want to find out if this has a relative maximum or a minimum. So we'll take a look here. I need to find g prime of 0. I want to get g prime of 0. We've done this before. That is looking at where the 0th derivative is. So g prime of 0 over 0 factorial, that has to be 3. So g prime of 0 is 0. And next I need to find the derivative. I don't really, oh, sorry. This is awful. I messed that up big time here. Let me rephrase this, okay? There we go. I want to fix that. So to get g prime of 0, there is no first derivative term. So g prime of 0 is 0. So this is a critical number. Next, we're going to use a second derivative at 0. over 2 factorial, and that's going to equal where the second derivative occurs, which is right here. We're only looking at the coefficient, so that -4 right there. I'll show you another way we can do this in a second. So therefore, the second derivative at 0 is going to be -4 times 2 factorial, which is less than 0. That's telling me it's concave down. So that's concave down. So therefore, we can say g of 0 is a relative maximum because the first derivative at 0 is 0 and the second derivative at 0 is positive. So another way I can get it, let's say if I want to find it, I want to find the second derivative at 0. Another way to look at it is I can use my Taylor. Taylor is this: x minus c to the n. Well, I want n to be 2. Well, where does that occur in my graph? At this -4. So if I let n be 2, and my center is at 0, 2 factorial, x squared, that has to equal my second term here, this -4x squared. The x squareds cancel, and I can solve it. -4 times 2 factorial. All right. Hope you enjoyed the video. I'll see you later.